Like many lessons, this is going to be a partial review and partially new stuff. Quadratic functions are functions that have an x squared in them. They're parabolas. We've been graphing parabolas for a while as part of transformation of base points, but you can always remember that because quadra or quadrare means to square, and that's where the x squared comes from. Two primary forms of quadratic functions. We have the quadratic form, which is the one that looks like the quadratic equation comes from. F of x is equal to ax squared plus bx plus c. And then that can only be when a is not equal to 0. And then graphing form, f of x is equal to a parentheses x minus h squared plus k. That's the form that lets us know what the vertex is. The vertex would be hk is the vertex, the max or min of the parabola. We also know from that the vertical line x equals h is the axis of symmetry. We've been using the axis of symmetry to plot the opposite side of base points whenever we have them. We also know that if we have an a value that's greater than 0, that means that the parabola is upward shape, it opens up, and that if we have a is less than 0, we know, and if a is less than 0, the parabola is downward and it opens down. That means if a is negative. So given all that, we have many methods with which we can graph this stuff. Method 1 is using the calculator just to find the max and min values, because of what we're entering into is a situation where finding the max or finding the vertex, which we can describe as the max or min of the calculator or the parabola, is going to be a huge part of what we do. Method 2 is one we've done before. It's called completing the square. It means putting this quadratic form into graphing form. If I take this and I group the two x terms, and I look to see what do I need to complete the square, my next step would be to say f of x is equal to x squared plus 8x plus something, and I'm going to put that in parentheses, and then minus, or plus 9, and then minus that same something. I'm adding, and then I'm subtracting to keep the side value the same. Whatever you add, you have to subtract. Then we look at half of 8 squared, same thing we did with circles. Half of 8 squared is 16, and then I have 9 minus 16. Factor, and we get f of x equals x plus 4 squared minus 7. We now know what the vertex is. We have it in graphing form. We could do transformation of base points on this. We can also graph it by saying that we know the vertex is -4, -7. So let's plot that. I know that my axis of symmetry is the vertical line x is equal to -4. So let's plot that. There's a vertical line at x equals -4. Not part of the parabola, but a line of symmetry. If I'm going to describe other characteristics of this, I know it opens up because my leading coefficient is positive. I know that if I plot intercepts, let's do this set of intercepts. Let's do the x-intercept. To find an x-intercept, you set y equal to 0. I'm going to look at this one, and I'm going to set y equal to 0 and say 0 is equal to x plus 4 squared minus 7. Add 7 to both sides. Take the plus or minus square root of both sides, so I get plus or minus radical 7 is equal to x plus 4. And x is equal to -4 plus or minus radical 7. If I want to plot those, I have to get the approximate values, so I plug those in a calculator. I get approximately -1.4 and 6.6. So those are two values that we can plot. Sorry, -6.6. So -1.4 would be somewhere like here, you know, like -1.5 almost. And -6.6 would be 1, 2, 3, 4, 5, 6, and then somewhere like in here. Those are symmetrical about the x-axis, or about the line of symmetry, so I know I did that correctly. Then we're going to find the y-intercepts, which are very easy if we look at the original function way up here. If I pull from there and I plug 0 in for x, I get 9 for y. So that means 0, 9 is my y-intercept. Let's plot that. Then we're going to go the same point on the opposite side of the axis of symmetry. And then I have enough points. Now I want to show you that we could also do transformation of base points on these. If I want to get more base points, I could go 0, 0, 1, 1, and 2, 4, and that becomes my h is equal to -4, a is 1, and k is -7. So I'm subtracting 4 from all my x's, -4, -3, -2, and I'm subtracting 7 from my y's, -7, -6, and -3. Those give me some more points, -4, -7, which we already have as our vertex. -3, -6 would be here, and -2, -3 is here. And if I plot those on the opposite side, I get this point and this point. So those are a lot of points, and if we connect them all, we get a pretty good parabola with many points, all of significance. Let's go on to the next one. If I scroll down to this one, I have a little bit more of a challenge in completing the square. What I have to do is group the first two terms together and pull out a 2. We can't have any coefficients when we do this completing the square thing. So I'm going to pull out a 2 and I get x squared minus 5 over 2x. Then I'm going to do the box step. I'm going to add a box, and then I have plus 3, and I'm going to subtract a box, but I have to stick a little growth or addendum on that because I factored a 2 out, and this box right here is really a 2 times a box. So I have to subtract 2 times a box. I'm going to stick the little 2 there to match this 2. Actually, I'm going to highlight those so that they match. This 2 is the same as this 2. Okay, then we say, what is half of 5 halves? Half of 5 halves is 5 fourths, and then 5 fourths squared is 25 over 16. Let me zoom in so I can get a better writing of this. 25 over 16. And then I'm going to put a 25 over 16 here. If I write this now, I'm going to write it as f of x equals to factor. This is x minus 5 fourths, quantity squared. And then that would be plus 3 minus, that'd be 25 over 8. 3 minus 25 over 8 is 24 eighths minus 25 eighths. So when I subtract that, I actually get, I'm just going to erase this, since you can rewind and see it if you need to, I get -1/8. So that's my graphing form. Let's go through the same process we did before with vertex, is positive 5 fourths, -1/8. Vertex is that. Axis of symmetry, which I'm going to abbreviate AOS, is x is equal to positive 5 fourths. So that's my axis of symmetry. Then, let's see, my, what else do we do? We know it opens upward because it's a positive 2. Let's do intercepts. Actually, let's graph a little bit on here. If I look at the graph, maybe I'm going to want to make every box be different. You know, I've got fourths and eighths, so I have a vertex at 5 fourths and -1/8. Let's make every box be a fourth and see if that works out okay. So I'm going to go over 5 fourths and down 1/8. That would be right here. Again, I'm counting by fourths. With an axis of symmetry at x is equal to 5 fourths, just a vertical line kind of dashing down through there. X-intercepts, we set y equal to 0. 0 is equal to 2 times x minus 5/4 squared minus 1/8. If I add 1/8 to both sides and multiply by 2, or divide by 2, sorry, I get 1/16 is equal to x minus 5/4 quantity squared. Take the plus or minus square root of both sides, and I get plus or minus 1/4 equals x minus 5/4. Add, and I get x is equal to 5/4 plus or minus 1/4, which is the same thing as 3/2 or 1. So keeping in mind that I counted by fourths, 1 would be here, and then 3/2 would be here. So that plots intercepts. Now y-intercept, if I put a y-intercept down, I plug in 0 for x, and I plug it back into the original equation, so I have y is equal to, if I put it back into the original one, the 2x cancels out, the negative 5x cancels out, and I get positive 3. And since I counted by thirds, I'm going to be off the grid here, because that is 1, that is 2, so 3 would be way up here. I'll just put the other one here too. It should be like over here. Let's not do transformation of base points on this one. Let's just graph it, call it a day, since those transformations are going to be a little bit touchy. Let's go on to the next one. What I'd like you to do actually is pause the video and go ahead and do this one, and then kind of skip ahead and see if you got it right. But I'll go ahead and walk through it right now. We got grouping these. I'm going to pull out a negative 3. You get an x squared minus 4/3 x. I still have the minus 1. I'll do y equals. Then I'm going to say, okay, so what is half of 4/3 squared? Half of 4/3 is 2/3. 2/3 squared is 4/9. Then I have minus 1 minus, it's going to be 4/9, the box of negative 3. So then I have y is equal to negative 3, x minus 2/3. That's going to be negative 1 plus 4/3. 4/3 minus 1 is 1/3, so this is going to be 1/3 plus 1/3. Vertex, 2/3, 1/3, axis of symmetry, x equals 2/3. This is a downward shaped parabola. My y-intercept, sorry, let's do x-intercept. My x-intercept is going to be 0 is equal to negative 3, x minus 2/3 plus 1/3. Subtract 1/3 and divide by negative 3, and I get 1/9 is equal to x minus 2/3 squared. So plus or minus 1/3 is equal to x minus 2/3. X is equal to 2/3 plus or minus 1/3, which is equal to 1 or 1/3. Let's graph this stuff, plotting by thirds. So I'm going to go, vertex is 2/3 up 1/3. Then my y-intercept is negative 1, which is going to be down 3 boxes. My x-intercept is here and here. Here's my vertical axis of symmetry, going through x equals 2/3. And then let's plot the other side of the y-intercept, and I'm just going to connect these. Okay? Alright, let's skip over to method 2 now. Or sorry, method 3. Method 3 is finding the vertex directly from the equation. And here's the whole deal with this. We know that the x-intercepts, aka the roots, are the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We also know that halfway in between the two roots of any curve is going to be the x value of the vertex. So my axis of symmetry is going to be a little bit weird here. Actually, we can build this. We can say it's an x equals, it's a vertical line, but it's the average of the two roots. Think about it. The average of the two roots' x value is going to be my axis of symmetry, because halfway in between my two roots is the vertical axis of symmetry. So I'm going to take one root, negative b plus radical b squared minus 4ac all over 2a. Then I'm going to add negative b minus b squared minus 4ac all over 2a and put it all over 2. Take the average of the two different roots. Well, as you can imagine, that's going to simplify a lot. It's actually going to be negative 2b over 2a all over 2, which is the same thing as negative b over a over 2, or negative b over 2a. So, x equals negative b over 2a is the axis of symmetry. Furthermore, my vertex has an x value always of negative b over 2a. And the y value is just f of negative b over 2a. Just take that x value and plug it in and you'll get the y value. There's the vertex. It can be simpler sometimes. It can be a little bit more math sometimes. We're going to do an example and see if you like it. Here's an example of number 4. Our axis of symmetry is x is equal to negative b over 2a, which is negative 4 over 2 times 1, which is, 2 times 1, which is negative 2. That's my axis of symmetry. Okay, now let's just do f of negative 2 to find the y value. I'm going to go negative 2 squared plus 4 times negative 2 minus 3, which is 4 minus 8 minus 3, or negative 7. Oops. So my vertex is negative 2, negative 7. And my axis of symmetry is x equals 2, and this is an upward parabola. If I just go ahead and then find my y-intercepts, my y-intercept would be negative 3. If I just kind of look at the original equation, my x-intercepts, if I'm using the quadratic formula here, I might as well just go ahead and finish it. Negative 4 plus or minus square root of 16 minus 4 times 1 times negative 3 all over 2. And I get negative 4 plus or minus square root of, that'd be 28 over 2. Or negative 4 plus or minus 2 root 7 over 2, or negative 2 plus or minus root 7. Not pretty, but I have the two x-intercepts. If we want to approximate, we know that root 7 is just a little bit between 2 and 3. So let me find a value real quick. Root 7 is like 2.6, so that's equal to 0.6 and negative 4.6. So if we plot all this stuff, negative 2, negative 7, we have 0.6 and negative 4.6. And my x-intercept was negative 3, and then we have that over here too. And then we just do an axis of symmetry and plot the two sides of the parabola. Okay, that's all for graphing parabolas. We have a few little details to kind of take care of. We have this thing called the discriminant. This should be review for you. In the quadratic formula, x is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This thing here is called the discriminant. Discriminant is b squared minus 4ac, because that's going to determine the nature of the roots. It lets us know kind of what the parabola is going to look like. Here's case in point. Case 1, my b squared, and on all of these we're going to do b squared minus 4ac here 6 squared minus 4 times 1 times negative 2 is 36 plus 8, or 44. This is the case where the discriminant is positive. A positive discriminant means that in the quadratic formula we're just going to have an imperfect root. And on a graph, that just means we're going to have two roots. The graph is going to look something like this, or something like this. And from a graph perspective, what that means is we're going to have two rational or irrational roots, just depending on whether we have a perfect radical or not. There are two x-intercepts here. Whether we have the blue graph or the red one, those are different ones, but whether it's up or down, we have two roots. Let's go back up here. Let's check out this one. B squared minus 4ac is going to be 144 minus 4 times 9 times 4, which is 0. Which means that my quadratic formula is just going to be negative b over 2a, because there's no plus or minus square root of, so it's the square root of 0. That means we have one root, and one root does this thing. Whenever we have one root, it's a double root. It taps at the vertex, or it taps here at the vertex, up or down. We just say we have one double root, which means we have one x-intercept. Let's go up here. B squared minus 4ac would be 36 minus 4 times 1 times 10, which is negative 4. Well, the square root of negative 4 is an imaginary number, so our graph never crosses the x-axis, which means that an up graph would look something like this, and a down graph would look something like that. We say we have two complex conjugate roots. We can't graph them because they're complex, so there's no x-intercepts. Okay, those are describing some things. Now, last little point here, which geometric figure, this is a good question that's going to lead us into the word problems of the next day. Which geometric figure with the same perimeter has the maximum area, square or triangle? I'm going to demonstrate this to you. This is an excellent point. Pretend this is a square, and pretend this is a rectangle, and that they have the same perimeter. Now, if we say a square had a side length of x and x, what we can say is that the rectangle has a side length of x plus a, and then x minus a. Because if I took the perimeters and added them all up, the perimeter of all of these objects would add up to 4x and 4x. So that satisfies the condition that they all have the same perimeter. Now my question is, what's the area? The area at the left here is x squared. The area to the right is x minus a times x plus a, which is the same thing as x squared minus a squared. My point is that if you look at the square, that's always going to be a bigger number than this. X squared will always be greater than x squared minus a squared, no matter what that a is. Unless that a is 0, and then they're the same thing. So I'll say greater than or equal to. But that's a visual and mathematical proof that to maximize area, you need a square. To maximize the area at the parabola, the max or the min, you need a perfect square trinomial. You need to know what that vertex is. So, anyway, that's the end. I'll go ahead and do right on your home. Well, you can look up your homework.